Hey, physical science, it's Tuesday now, and we're starting a new chapter. This should be April the 7th. Turn your books with me to page 468 and get out your periodic table of the elements. Yeah, it's time for chemistry to begin. But guess what? We're not in school. I don't get to give you one of those, but I believe there's one on the inside of the textbook. So go ahead and take a look there. In fact, I got this book here. Good thing. Oh, look at that. There's a periodic table right inside the back cover. As I refer to it, you can refer to that periodic table, and I'm going to start on 468. I'd like for you to draw that flow chart with me. Matter at the top. Now, matter is defined as anything that has mass and takes up space. So I call it mass and volume because taking up space is volume. So the definition is anything that has mass takes up space. So matter is stuff, as opposed to energy. Energy is not stuff. Okay, so matter can be broken up into two categories. This is an old-fashioned flow diagram. I've already said that. Mixtures and pure substances. Right now, you should be drawing this on a piece of paper while you take the notes. Pure substances. Sometimes it's called substances. Okay. Now, mixtures can be broken down into, well, let's go to pure substances first. Elements or compounds? And what you're going to ask, what is it that makes them pure? I'll tell you in a minute. Mixtures can be broken down into heterogeneous or homogeneous. Heterogeneous, some people call it homogeneous. I call it homogeneous. Mixtures. We'll do pure substances first. What do you think elements are? The basic building block of all materials. Elements are on this periodic table of elements. If it isn't on this table, it's not an element. Is water an element? No, it's a compound. Is salt an element? No, it's also a combination of elements. Elements are the building blocks. You might call them the letters. And then compounds are called the words, if you please. You put these elements together and they chemically bond together. There's ionic bonding, there's metallic bonding, there's covalent bonding. We're going to learn more about that later on. But just know that they are bonded together chemically. You cannot reach into water. Here, let's take some water. You can't reach in there and pull the oxygen away from the hydrogen. It takes an electrolysis to do that. An electrolysis apparatus like the one I have right over here. You see it? You see it in the front of my classroom, haven't you? And we take electricity and we break that water down into hydrogen and oxygen. And that is up here on the top of these burettes. Okay. So water consists of two gases chemically bonded together. Isn't that crazy? And so water is a compound. Well, anything on this table here is an element, and compounds are composed of elements. Okay, and then look at this table on page 468. Do you see where elements are like oxygen, gold, and iron? Okay, so finding these things on this table is the hardest part. Oxygen is over here. Gold is right here in the gold triad. Gold, silver, and copper. Those are coinage metals because they make coins out of them. You've got common things like zinc, and we've got aluminum. We got sulfur. We got some gases, noble gases they call them. We got some gases right here. Well, they're typically gases at room temperature. This down here is not. That's a liquid at room temperature, and these down here might be solid. Okay, but solid does not mean metal. Metal can be a liquid also if you heat it up. Liquids just mean, metals just mean that they're capable of conducting electricity and heat. They're capable of being smashed into a thin sheet. We're going to talk more what characteristics of metals are. Metals are over here. Non-metals are over there on the periodic table. Metalloids are right down the middle. We'll talk about that later. There's some common metals that you think of: sodium, magnesium. Sometimes you think of chromium, like bumpers and all that kind of thing. And copper, I've already talked about copper and silver and gold and iron. Yeah, and aluminum. Those are all on the periodic table. Now, compounds. On your book, they talk about salt, baking soda, and sugar, composed of elements, atoms of elements. Atoms are one singular unit of an element. Okay, let's go ahead and take salt and put it in water. There we go. Now we have salt dissolving in the water. That forms a compound or a mixture of compounds. Salt is what we call sodium chloride. Let me go ahead and write it in chemical form, since that's what we're starting to understand. Salt is sodium chloride, consisting of the elements sodium and chlorine. Other elements might be gold, and iron. But this particular compound is composed of the elements sodium and chlorine. And when you combine them in a compound, you call them chloride. Sodium chloride is an example of a compound. What's this compound? Water, H2O, 2 atoms of hydrogen with 1 atom of oxygen. And when these things get together, the water dissolves the salt, but you can get the salt back if you evaporate the water from the saltwater solution. You put a flame on this, boom, the water goes away and the salt stays behind. Now, something interesting happens when you make that solution. It breaks the salt crystal down, and it breaks the formula unit right here of every formula unit is broken down into charged particles called ions. And we'll talk about that later. Sodium ions are positive, chloride ions are negative. But let's just say that the salt dissolves in the water. So that makes a salt-water mixture, which is homogeneous. Salt and water is called aqueous salt, meaning dissolved in water. It's a hydrate. A solution with water as the solvent is called a hydrate. It's hydrating. And you have to have certain salts in your body, in your in the foods that you eat, in order to get your brain to work correctly, because your brain works on electricity, and these charged particles that break down in the water help you to think straight. Okay, so that's a mixture that is evenly spread throughout. Let me taste it. You ready? Salt water. Salt water. Everywhere you taste, everywhere you look, that salt is going to be evenly spread throughout this container. So what that means is it dissolved. And so you can't go anywhere. Right here, I'm breathing air. Air is a homogeneous mixture. There's another name for a homogeneous mixture. I just said it a minute ago. It's called a solution. And the homogeneous mixture of metals, where they basically melt metals together, is called an alloy. And I'll put that over here. It's a special type of homogeneous mixture. The wet ones, the ones that involve a solvent, are called solutions. And so the sodium chloride solution is evenly spread throughout. That makes it homogeneous. Well, what's a heterogeneous mixture? Well, it's when you're combining stuff that is not evenly spread throughout. I have a mixture right here of salt and water and marking pens. Now I have another mixture of salt and water and marking pens, but you have more marking pens, but it doesn't matter. It's a mixture of those three things. So with heterogeneous mixtures, it can be various composition. You can have 2 marking pens and 3 grams of salt in 100 milliliters of water. Or you could have less water and a little bit more salt and more marking pens, and it's still considered a mixture. Because mixtures, whether they be homo or hetero, can be indefinite composition. But solutions, the homogeneous mixture, can it be an indefinite composition? Yeah, we put a little bit of salt in that water. Now we're going to put a little bit more. It doesn't say that you have to have salt and water in a 1-to-1 relationship by mass. You can have a little salt in a lot of water or a lot of salt in a lot of water, as long as it isn't reaching its saturation point. Okay, so mixtures are indefinite composition. What about pure substances? They're definite composition. What do you mean by that? I mean, with sodium chloride formula units, it's always 1 sodium with 1 chlorine atom. With water, it's always 2 hydrogen atoms with 1 oxygen atom. It's a 2-to-1 ratio. Or if you look at it from oxygen to hydrogen, it's 1-to-2. There's another compound by the name of hydrogen peroxide. H2O2. Hydrogen peroxide comes in a brown bottle. And you know that that is not the same as water. It's a different substance, a different pure substance. It has its own ratio that doesn't change. Ratio of atoms to atoms doesn't change, so it's a definite composition. Elements, that's definite composition. Now, what among this is the only one that is a pure substance? Of course, the aluminum foil. It is a element. This is a mixture of salt and water. Which one of these is a pure substance? They both are. This is an element. This is a compound. That's sodium chloride. This is aluminum. That's enough of that. I'll see you next time around.